All right, question 1. Now, these are all exact values you can see, so we're going to need our special triangles. First one is our 31 to root 3, but of course we're not going to use 30. We're going to use pi on 6, making the other one pi on 3. Our other special triangle is our 45, 1 root 2, but it's not 45, it's pi on 4. Now, they're just after acute angles here. They've specified acute angles, so we're not going to have to worry about figuring out all the values around the 360 degrees or 2 pi radians that give us the same answer. We're just going to have to do the ones in here. So, I mean, technically, you could literally just do arctan 1 in your calculator. I'd like you to use the triangles, though. Now, we know tan theta is 1 over 1. That's going to give us pi on 4. That's the only one that gives us that. So that's theta equals pi on 4 is the solution. To get sine a half, for sine to come out as a half, it must have been pi on 6. So theta is pi on 6. For cos to come out as 1 and root 2, it must have been pi on 4. For tan to come out as 1 on root 3, we must have been, remember it's opposite over adjacent, must have been pi on 6. For sine to come out as root 3 on 2, opposite over hypotenuse, we must have been pi on 3. For cos to come out as a half, adjacent over hypotenuse, we must have been pi on 3. This time, we need to figure out the value between theta and pi on 2 that satisfies this equation. Now that again tells us that it's acute. So we're just in here, so we don't need to figure out all the other ones that would work, yeah? You do need your calculator to be in radians mode. So we're doing x equals arctan 3. That gives us... So I'm in radians. Remember to change it to radians. You go degree mode, shift setup, and then choose 4 for radians. And there's an R telling us. So we're going to do arctan 3, I think it was, 1.249. 3 decimal places. And you're going to do the same for all of these. Arcsine 0.8, 0.927. Arc cos 0.4, 1.159, and I should be doing x equals because we're solving equations here. So here we're doing arc sine 0.234, x equals 0.236, arc cos 0.987, x equals 0.161, finally arctan 100, x equals 1.561. Now we need the all the way around. Between 0 and 2 pi, all the way around. So sine x equals a half, x equals pi on 6. So that's here, yeah? But it would have also been positive here, where this is pi on 6, which means we need to do pi minus pi on 6, that's 5 pi on 6. I figured that out because pi minus pi on 6 is 5 pi on 6. But 1 minus 1 6 is 5 6. So that's what I actually put in my calculator. And then I just put pi's with it. Cos x equals negative a half. So for cos to come out as negative a half, it would have been pi on 3. But because it was pi on 3, negative pi on 3, this is the first value. Negative a half. This is the first value, so coming up here would have been pi on 3 because it came out as negative. So that gives us 2 pi on 3. The other value that would have given us a negative would have been down here. So pi plus pi on 3, 4 pi on 3. Tan x equals minus 1. Well, for tan to be 1, it's 45 degrees. For it to be minus 1, we must be over here for the first one. So it must have been 45 coming up that way, which is pi on 4, which means it's 3 pi on 4 coming around this way, because 1 minus a quarter is 3/4. You're going to have to get good at those fractions. So the first one, x is 3 pi on 4. The other value that would have given us a negative for tan is not down here because this would have given us positive. It's down here. So it would have been pi on 4 down from here. If we want to go all the way around, then that may as well be 2 minus a quarter, which is 7/8. No, 7 on 4. So 7 pi on 4. Okay, sine x equals 1. For sine to be 1 on 1, it's 90. Because we must be going straight up. Two cos x equals root 3. This means cos x equals root 3 on 2. So for x to be for it to be root 3 on 2, for cos to be root 3 on 2, we're pi on 6. The other value that would have given us positive pi on 6, so pi on 6 is up here, would be down here. The other one that gives us positive pi on 6. To figure out all the way around, it's 2 minus 1/6 equals 11 on 6. So it's 11 pi on 6, because 2 is 2 pi. 12 pi on 6. Okay, root 3 tan x equals 1. So tan x equals 1 on root 3. So x is then, for tan to come out as 1 on root 3, let me get rid of these. It would have been pi on 6. The other value that gives us a positive is down here, so it's pi on 6 down here. Pi plus pi on 6 gives me 7 pi on 6. Because 1 plus 1 on 6 is 7 on 6. Cos x plus 1 equals 0. This means cos x equals negative 1. For cos to be negative 1, we must be here. That's right, isn't it? Yep. Oh, it's not negative pi, it's just pi. You could literally just chuck arc cos of negative 1 in your calculator and it gives you 3.14, and you should recognise that as pi. A lot of these you'll start recognising. Talk to me in person if you want to know the quick way to do these without the stuff. Okay, here we've got root 2 sine x equals -1, which means sine x equals -1 on root 2. For sine to be -1 on root 2, we must be 45 degrees, but because it's negative, it's going to have to be 45 down here, which is pi on 4, or 45 down here, pi on 4. So for the first one, we've got x equals, well, it's pi plus pi on 4, so it's 5 pi on 4, x, now 2 pi minus pi on 4, 7 pi on 4. Okay, solve each equation all the way around. Remember that a positive number has 2 square roots. So for these ones, we've got sine squared theta equals 1, which means sine theta equals +1 and sine theta equals -1. Because +1 times +1 is 1, -1 times -1 is 1. So theta equals arcsine 1. So sine theta comes out as +1 when you're 90 degrees, which is pi on 2. Comes out as -1 when you're 270 degrees, 3 pi on 2. And they're your two values. If we've got, so this was A. If we've got tan squared theta equals 1, that means tan theta equals 1, tan theta equals -1. Tan theta equals 1. Then theta equals, we're looking at 1 over 1, which is pi on 4. But the other value that's going to give us +1 is going to be down here. Pi plus pi on 4, 5 pi on 4. Tan theta equals -1. This time, we're here and here. So this time we're 3 pi on 4 and 7 pi on 4. Okay, let's do C. Cos squared theta equals 1/4. So cos theta equals positive square root of 1/4 and negative square root of 1/4. Now positive square root of 1/4 is 1 on root 2. Well, we've got -1 on root 2. So theta, cos comes out as 1 on root 2 when it's 45 degrees, which is pi on 4. The other value that'll give us a positive for cos is going to be down here, pi on 4 down, which is 7 pi on 4. For it to be negative, instead we're going to be here and here. So this is pi on 4, this is pi on 4. So we've got 3 pi on 4 and we've got 5 pi on 4. And for D, if I can fit it in, cos squared equals 3 on 4. So we've got cos theta equals square root of 3 on 4, so root 3 on 2. Cos theta equals negative root 3 on 2. Now cos comes out as root 3 on 2 for pi on 6. Looking at this one. Look, zoom in. Let me zoom in. Cos, yep, pi on 6. The other value that's going to give us a positive, so pi on 6 is, we want this way, so 2 take 1/6. 11 on 6, so it's 11 pi on 6. Here we've got negative root 3 on 2, so this time we're going to be in the other two, there and there, pi on 6, so 1 pi take pi on 6, so 1 take 1/6, 5/6, so 5 pi on 6 1 plus pi on 6 will be 7 pi on 6. So they're all the values all the way around that give us those answers. So yeah, these can be really fiddly. They're worth practicing with. Question 6 gives us another example of a fiddly one. So for A, we've got tan squared minus tan theta take 2 equals 0. So if we let u equal tan theta, well, tan squared theta will now be u squared. Tan theta will be u minus 2 equals 0. If we factorise this, or you can solve it with quadratic formula, I'm going to factorise it. U take 2 u plus 1, because negative 2 is negative 2 times 1, negative 2 plus 1 is negative 1, yeah, we're good, equals 0, so u equals, question B, we're on to question B now. U then equals 2 and u equals negative 1. Question C now wants us to solve this, so we've got tan theta equals 2, tan theta equals negative 1. Now, we want this all the way around. Tan theta equals 2, that's not one of my special triangles, so I'm going to do arctan 2. If I sneakily do that in my calculator in degrees, then that gives me 63.43 degrees. The other value, so that's 63. The other value, SATC, that would be positive, is, 180 plus 63, so 243.43 degrees, but we want them in radians. So we've got 1.107 radians, and that plus pi, 4.249 radians. When we've got theta equals arctan negative 1, we do have a nice one that gives us negative 1. When tan comes out as 1, that's 45, isn't it? 45 is pi on 4. Pi on 4 up would be positive. If it wants to be negative, it's going to be here and here. So we've got pi take pi on 4, like it's pi on 4 back from pi. And we're going to be pi on 4 back from 2 pi, which is 7 pi on 4. That's question 6. We're just doing the left-hand side of question 7, because these will all take a little while, and they're all going to be annoying. So we're going to develop a fairly standard way for approaching these. So we've got tan squared theta plus tan theta equals 0. So step 1, let u equal tan theta. So we've got u squared plus u equals 0. So we've got u plus 1 equals 0, u equals 0, and u equals 1. Step 2, solve each of these. Tan theta equals 0. Tan theta equals 1. Now tan comes out as 0. When it's 0 degrees, remember it's opposite over adjacent. So you're looking for every time that the opposite is 0. So that's 0 degrees and 180 degrees, so it's 0 and pi. Tan theta equals 1. That's our 45, that's pi on 4. And it's positive 1. So we know we're also looking for this one. So we've got pi plus pi on 4. Now if we've got pi plus pi on 4, that's the same as 4 pi on 4 plus pi on 4, which is now 5 pi on 4. So you essentially get the bottom number and plus 1. For question C, we're going to do the same approach. Sine squared theta plus sine theta take 2 equals 0. So the first bit is to let u equals sine theta. So we've got u squared plus u take 2 equals 0. Factorising is going to be easier than using the quadratic formula. So you've got u plus 2 u take 1 equals 0. So don't forget, it's what multiplies to give negative 2 that adds to give positive 1. So u equals minus 2 and u equals 1. Now, that means sine theta equals minus 2 and sine theta equals 1. If sine theta comes out as negative 2, wait, did I do that right? Plus sine theta yeah, I did that right. Sine is always less than 1, so no solution. And if you'd actually chucked arc sine, and it's always a good thing of last resort to do, in your calculator, you would have gotten math error. But we can do sine theta equals 1. Do it in your calculator if you're unsure, and I usually do that with these ones. Now 1.57 is the same as pi on 2. Which makes sense, because this is 1, this is 1, this means this must be 0, so we must be straight up. And if it's going down, it would have been negative 1. So theta equals pi on 2 is our only solution. Oh, let me move this question a bit further down, we need more space. Okay, question E. We've got 2 cos squared theta plus cos theta take 1 equals 0. So we're going to let u equal cos theta. So that means we've got 2 squared plus u take 1 equals 0. Now you could quadratic formula this one if you wanted, but I'm going to PSF it. So 2 times minus 1 equals minus 2. Minus 2 equals, well, 2 times minus 1. So I could rewrite this as 2u squared plus 2u take 1 equals 0. So I've got 2u outside of u plus 1, take u plus 1. So I've got u plus 1, 2u take 1 equals 0. So I've got u equals negative 1 and u equals positive 1/2. So step 2, I've got cos theta equals negative 1, cos theta equals 1/2. Now, if you just do arc cos -1, that'll give you pi. Of course, we do know a half. Uh, 31 to root 3, 60. When cos is a half, that means we were pi on 3. The other value that would give us a positive for pi on 3 is going downwards. Now to figure out that one if you want, you could do 2 pi minus pi on 3. So we've got 6 pi on 3 minus pi on 3, so it's 5 pi on 3. Okay, last question for this one, G. We've got 3 sine squared theta plus 8 sine theta, take 3 equals 0. So step 1, let u equals sine theta. So we've got 3u squared plus 8u take 3 equals 0. You could quadratic formula this, but I know that 3 times -3 is -9. -9 equals 9 times -1. 9 plus -1 equals 8. Good. So I've got 3u squared plus 9u take 1u take 3 equals 0. So I've got 3u plus 3 take u plus 3 equals 0, and that's a 1 out the front of that one. So I've got 3u take 1, u plus 3 equals 0. So we've got u equals a third and u equals -3. Part 2, so we've got sine theta equals 1 on 3, sine theta equals -3. Now if you wanted to do this one, you do arc sine -3, and that comes out as math error. So we've got no solution for that one, so we're just caring about the 1/3. We don't have a special triangle for sine coming out as a third, so we're just going to have to do theta equals arc sine a third. They want the answer in radians, so make sure you're in radians. So that's 0.340 radians, I've rounded. Now to put that into perspective, I like to draw it. I like to turn it into degrees sneakily, so I'm going to put my calculator in degrees and do the same calculation. Arc sine 1/3. So that's like 19 degrees. It's also going to be positive here. So we've got to do pi minus that. So if we want to do pi minus arc sine a third, I need to be in radians again. .802. So I've got 2 answers there. All right, I'm going to need more space. Question 8, I think I've asked you to do all of them. Yep, so this is 9 for advanced, 8 for extension. So this one's less easy. If we've got 2 sine squared x plus cos x equals 2, usually when they're talking about trig identities, they mean sine squared plus cos squared equals 1, or, and I can never remember the tan squared plus 1 equals sec squared. If we rearrange the first one, that means sine squared x is 1 minus cos squared x, or the other way around, cos squared x is 1 minus sine squared x. Here, if we wanted this the other way around, we'd have tan squared x equals sec squared x minus 1. So for A, I'm going to take sine and I'm going to replace it with 1 minus cos squared. So I've got 2 lots of 1 minus cos squared x plus cos x equals 2. The reason I chose to do that was because I had cos x on its own here and I knew I couldn't replace it with anything. Which means I've got 2 minus 2 cos squared x plus cos x equals 2. Which means I've got, honestly, I'd rather have like a positive in front of that cos squared. So, hang on, negative 2 cos squared x plus cos x is going to come out as 0 because I've subtracted 2 from both sides. So I'm going to replace let cos x equal u to make things a bit tidier. Negative 2u squared plus u equals 0. So if I factorise it out, I've got u outside of negative 2u plus 1 equals 0. So u equals 0 and negative 2u plus 1 equals 0. Negative 2 equals negative 1. Negative 2u, sorry, equals negative 1. U equals a half. I'm going to continue going on the other side of this. So u equals 0, u equals a half means cos x equals 0, cos x equals a half. Now we know cos x equals 0 when x equals pi, so it's 180 degrees. We know cos x equals a half when x is, now that's going to come out as a half when it's 60 degrees, pi on 3. And it's also, so that's pi on 3, SATC, coming down here. And if we do this, we've got 2 pi, take pi on 3, 6 pi on 3, take pi on 3, 5 pi on 3. Okay, question B. Yeah, I really underestimated the amount of room we'd need. My apologies. All right, question B. It is worth doing all these, by the way. This is kind of where the exam questions will come from for extension. So we've got sec squared x take 2 tan x take 4 equals 0. I'm going to replace sec squared with tan squared plus 1. So I've got tan squared x plus 1, take 2 tan x take 4 equals 0. Didn't need these brackets. This means I've got tan squared x take 2 tan x take 3 equals 0. So let u equal tan x. So I've got u squared take 2u take 3 equals 0. What multiplies to give negative 3 as to give negative 2? U take 3, u plus 1 equals 0. So u equals 3 and u equals negative 1. Now let's sub tan back in. Tan x equals 3, tan x equals negative 1. So 3 is not on any of our special triangles, so I'm just going to do arctan 3. So that's 1.249 radians. With tan, you can always just plus pi on to find the other one. So it's like just plussing 180 degrees to get into the tan quadrant, because remember we're here, so if we want to go down here, we just plus the full 180, so we're plussing pi. Gives us 4.391 radians. For tan x equals minus 1, this is a special one. This is 45 degrees, which is pi on 4. So for it to be negative, we want to instead be here. So pi on 4 back that way, so that's 3 pi on 4. And we want to be this way, so we had the 3 pi on 4 came from pi take pi on 4. If we're doing 2 pi take pi on 4, that's 7 pi on 4. Okay, question C. I'm going to, instead of having cos squared, I'm going to have 1 minus sine squared x. Because that's a 2 sine x, that's a sine x on the other side. So it's easier if everything's in terms of sine. So we've got 8, take 8 sine squared x equals 2 sine x plus 7. If I take everything over to the right, I've got 0 equals 8 sine squared x plus 2 sine x plus 7, take 8, take 1. What multiplies to give negative 8? That adds to give 2. I'm going to let u equal sine x. So I've got 0 equals, actually I'm going to write it the other way around, 8u squared plus 2u take 1 equals 0. Now if I want to actually do this, I've got 8 times negative 1 is negative 8. Negative 8 equals 4 times negative 2. 4 plus negative 2 equals positive 2. That's what I want. So I've got 8u squared plus 4u take 2u take 1 equals 0. So I've got 4u outside of 2u plus 1, take 2u plus 1. So I've got 4u take 1, 2u plus 1. So I've got u equals a quarter and u equals negative a half. Question, part 2, I'm going to sub sine x back in. So I've got sine x equals 1 on 4. Sine x equals negative a half. Now that negative half one we are going to be able to use a special triangle on, but 1/4 we aren't. So we're going to chuck it in our calculator. So we've got 0.25 3 radians. And don't forget, for sine, if we want it positive, we also want this one. So we're going to do pi minus that. That's going to be 2.889 radians. Okay, I'm going to move this one over here. Now, I know from my 30, so pi on 6, pi on 3, 1 to root 3, that x equals, now we want pi on 6 degrees, but it's negative. So it's going to be down here and down here. So we've got x equals pi plus pi on 6 is 7 pi on 6, because of course this is 6 pi on 6, like it always does that. And here we're going to have 2 pi minus pi on 6. So that's the same as 12 pi on 6 minus pi on 6, so 11 pi on 6. Question D. You kind of do a lot more in these next year, so please don't stress if you're struggling. I'm going to replace the tan squared with, tan is sec squared take 1. So I've got equals 5 sec x. So we've got 6 sec squared x take 6 equals 5 sec squared x, sec x. I'm going to let u equals sec x. So I've got 6u squared take 6 equals 5u. So I've got 6u squared take 5u take 6 equals 0. If we want to solve this, 6 times negative 6 is negative 36. Negative 6 is negative 9 times 4. Negative 9 plus 4 equals negative 5. Good. So we've got 6u squared take 9u plus 4u take 6 equals 0. So we've got 3u 2u take 3 plus 2 2u take 3 equals 0. So we've got 2u take 3, 3u plus 2. So we've got u equals 3 over 2 and u equals negative 2 over 3. Okay, sub it back in. So sec x equals 3 over 2. Sec x equals negative 2 thirds. Sec is 1 on cos, yeah? So that means cos x equals, turn it upside down. Now, neither of these are in our special triangle. So we're going to do arc cos 2 thirds. That's given us 0.841 radians. SATC, so we also want to go down from that. So we want to do 2 pi minus 0.841 radians, so 2 pi minus the answer. .442 radians. For r cos -3/2, this is going to end up as no solution, but let's just chuck it in our calculator. No solution. I think that's all of those ones. They are a slog. Like, that's something that I don't enjoy in trig. Okay, let's do the next lot. It's question 11 for advanced, so this is in challenge. It's question 10 for extension. And we're going to divide through by cos squared x. I'm going to show you what happens when we do the first one. So we'll have sine squared x over cos squared x plus sine x cos x over cos squared x equals 0 over cos squared x, which means this becomes tan squared x, because remember sine over cos is tan. This one, we've got the cos in one of these, so we've got tan x. And this one is 0. So let's let u equal tan x. We've got u squared plus u equals 0. U outside of u plus 1 equals 0. U equals 0 and u equals -1. Okay, let's find out when tan is 0 and tan is -1. Arctan 0, it's going to be 0. Arctan -1. And that's -pi/4. Which is the same as 3 -pi/4. So, sorry, I want to show you how I'm getting this. Oh, that's when it chucks a full circle, by the way. Now, I want to show you how I did this next one. I put arctan -1 in my calculator. And this is what you'll do every time you're kind of stuck. So we'll do arctan -1. Make sure we're in radians. Gave us a weird answer, yeah? But if we divide that by pi, it's -pi/4. So -pi/4 is the same as going down this way. So instead of writing -pi/4, we write all the way around. So we've got 2 pi, take pi/4, that's 2 take 1/4 is 7/4. And of course, because we wanted it when it's negative, it's also going to be negative here. So going back pi/4 from pi is 3 pi/4. Okay, question B. So if we divide through by cos squared x, we've got sine squared x on cos squared x. Take 5 sine x cos x on cos squared x plus 6 cos squared x on cos squared x equals 0. We get tan squared, take 5. Now we're going to end up with sine over cos, which is tan. And then the cos squareds cancel out. Still equals 0. So let u equal tan x. We get u squared take 5u plus 6 equals 0. Easy enough to factorize. We've got u take 6, u plus 1 equals 0. So u equals 6 and u equals -1. Tan x equals 6, tan x equals -1. So x equals arctan 6, which is 1.506 radians. And the other time we'd get that, so the SATC, we're up here, we want to be down here, so we've got pi plus that. 4.547 radians. Here, well, arctan -1. And that's negative pi on 4, which is we wouldn't write it as negative pi on 4, we'd write it as 7 pi on 4. And of course we want that one as well. Take away pi, we get 3 pi on 4. Question 11, I promise we're nearly there. Question 11 is actually easier, by the way. Like, these ones up here are what I consider the hardest. So we've got, the thing that's going to be tricky is they've restricted our domain really weirdly. Instead of being between 0 and 360, so 2 pi, we now want to be between pi and negative pi. So we've got sine 2x equals a half. So 2x is arcsine of a half, which, as you know from your special degrees, is 30 degrees. From your special triangles is 30 degrees, which is pi on 6. And it's also going to end up with pi on 6 is this one. We also want this one, which is 5 pi on 6. So x is, then we're going to divide both of those by 2, so we've got pi on 12 and 5 pi on 12. Question B. We've got cos 3x equals -1. So 3x equals arc cos of -1. Now cos comes out as -1 at pi, because that's when it's going to be -1/1. Let me get rid of that. So x equals pi on 3. Question C. We've got tan x take pi on 6 equals √3. So x take pi on 6 equals arctan √3. So x take pi on 6. Now arctan √3. Tan comes out as √3 when it's pi on 3. So 60 degrees. So remember, pi on 3, pi on 6, 1, 2, √3. So that's pi on 3. The other value where we're going to get positive pi on 3 is down here. So pi plus pi on 3 is 4 pi on 3. So x equals pi on 3 plus pi on 6. So a third plus a sixth is a half, so that's pi on 2. X equals now 4/3 plus pi on 6, 1/6, 3 pi on 2. Question D. Here we've got sec x plus pi on 4 equals -√2. This means 1 on cos x plus pi on 4 equals negative root 2. So cos x plus pi on 4 is negative 1 on root 2. Now cos comes out as 1 on root 2. 1 root 2 pi on 4. So it's going to be negative 1 on root 2 here and here. S-A-T-C. So x plus pi on 4 is 3 pi on 4, and x plus pi on 4 is 5 pi on 4. Except they wanted values between negative pi and pi, yeah? So instead of pi on 2 here, I would have had negative pi on 2. Instead of, in our final answer, yeah. Okay, so x, I'm going to subtract pi on 4 from both of these. So 3/4 take 1/4 is half. 5 pi on 4 take pi on 4 is just going to be pi. So 5/4 take 1/4 is just 1. Cool, we're still within our domain. Question E. Let me shrink this so I can, have a chance of fitting E in. Here we've got cosec. X take 3 pi on 4 equals 1. So this means 1 on sine x take 3 pi on 4 equals 1. So sine x take 3 pi on 4 is 1 on 1, which is 1. So x take 3 pi on 4 is arcsine 1, which means x take 3 pi on 4. There's only one value where sine whatever equals 1. It's 90 degrees, which is pi on 2. So x is going to be pi on 2 plus pi on 4, 3 pi on 4. A half plus 3/4 is 5 pi on 4. But they've restricted our domain. 5 pi on 4 is here. It's an extra pi on 4. They've restricted our domain to this bit and this bit. So because we don't want anything bigger than pi on just pi, we'll do 5 pi on 4 take 2 pi to get the other revolution. Negative 3 pi on 4. So instead of being considered as 5 pi on 4, we're going at it from the other angle, negative 3 pi on 4. Last one, F. I'm going to copy this in. So we've got cot, so we know 1 on tan x plus 5 pi on 6 equals root 3, which means tan, turn them both upside down, 1 on root 3, which means x plus 5 pi on 6 is arctan 1 on root 3. Now that is one of our special triangles. So we've got pi on 6, 1, 2, root 3, pi on 3. For tan to come out as 1 and 3, we must be pi on 6, so 30 degrees. The other value for tan that would have given us that, so we're pi on 6 down here. So that's pi plus pi on 6. So that's 7 pi on 6. Okay, so x equals 1/6 take 5 sixes is negative 4 sixes, so negative 2 pi on 3. 7 pi on 6 take 5 pi on 6 is 2 pi on 6, which is pi on 3. And both those answers are between pi and negative pi. This one. So Sine squared is 1 take cos squared. So I've got 4 outside of 1 take cos squared theta plus 2 cos theta equals 3. And here we're just the normal all the way around. So I've got 4 take 4 cos squared theta plus 2 cos theta equals 3. So I'm going to let u be cos theta. So I've got 4 take 4u squared plus 2u equals 3. I'm going to get everything over to the right. So I've got 0 equals, I've got 4u squared, take 2u, 3 take 4, take 1. If I now want to solve this, I'm going to use my quadratic formula. So I've got minus -2 plus minus the square root of -2 squared take 4 times a times c all over 2a. So I've got 2 plus minus the square root of 4 plus 16 all over 8. (20) can be simplified to, well, 20 is 4 times 5, so that's 2 plus minus 2 root 5. So I've got 1/4 plus minus root 3 on 4, root 5 on 4. So u equals 1/4 plus root 5 on 4, and u equals 1/4 minus root 5 on 4. Okay, now I'm going to sub those in, but I'm going to do it on the other side. Cos theta equals 1/4 plus root 5 on 4. Cos theta equals 1/4 minus root 5 on 4. So theta equals arc cos this. When I do that in my calculator, okay, I'm going to show you how I did this on my calculator, and then you're going to see how we got a good answer. So I'm going to do arc cos, we've got 1/4 plus root 5 on 4. Gives me something weird, yeah? But I know normally radians are expressed in terms of pi, so I'm going to divide by pi. And that gives me pi on 5. Of course, because it's cos and coming out as pi on 5, the other positive value is going to be down here. So 2 pi take pi on 5. So that's 9 pi on 5. For the other one, let's see if it comes out nicely again. So arc cos 1/4 take root 5 on 4. Divide the answer by pi. Yes. So this time I've got 3 pi on 5. And now 3 pi on 5, this, when you chuck it in your calculator, it's negative, isn't it? So 3 pi on 5 is over here. I'm going to draw myself up a different axes. I'm going to also want to be around to here. So I'm going to do 2 pi take 3 pi on 5. So that's 10 pi take 3 pi. So that's 7 pi on 5. So we've got our 4 answers. Pi on 5, 9 pi on 5, 3 pi on 5, and 7 pi on 5. And that is it. I know, that was a killer of a